Hi, honors physics students. Today we're going to talk about W5 wave phenomenon. And here you can see our wave standards that we're going to be looking at. And this one we're going to be looking at today, W5. What I want you to be able to get out of this is be able to describe the phenomenon. There are characteristics of waves. And these phenomenon that we're going to talk about them individually, are things that happen with waves but don't happen with things that are not waves. So things that are moving, when waves propagate, they all develop and they all show these particular phenomenon, and they're specific to waves. So let's go ahead, start getting into this. The first phenomenon that I want to talk to you about is reflection. And reflection is probably something that you're already pretty familiar with. The same reflection you have when you look in a mirror and you see your image reflected back to you. But reflection is not just a light or a visual effect. It happens with all different sorts of waves, sound waves, light waves, anything that's moving, any sort of disturbance that's moving. If it meets some boundary condition in the medium, it can reflect off of. So what is a boundary? A boundary is any intersection of two mediums. And this is where waves will reflect. And I'll take the example of a mirror. If you have your image, the light that's coming off of you approaching the mirror, it's traveling through air. When it reaches the mirror, the medium changes. It goes from air to the reflective surface. That reflective surface, because it has a medium change, the wave's energy, which is trying to push that way, can bounce off the surface, the boundary, and come back. Another example of a boundary would be an echo. Echo is an example of a wave that we're going to talk about in a moment. If you say we're at a cliff and you shout it, the voice, the sound of your voice, which is carrying through the air, would reach the surface of the wall. It would reflect off the wall and come back to you, and that's what we refer to as an echo. And I have a demonstration of an echo right here, a sound approaching some barrier boundary that you see on the right in green. And then it reflects back. So the sound going to it was in blue, the sound reflecting back was in red. So let's talk about what an echo is. If you hear the term echo, it is referring to reflection of waves, specifically the reflection of a sound wave. There's another term that we oftentimes use in conjunction with an echo, and this is something that you use echo to do, and that's sonar. Sonar, if you've ever seen a movie, maybe, or you observe someone or something, oftentimes with airplanes or in the military, they may be sending out sound waves into the environment. These sound waves, when they reflect off objects, they could use it to locate where some certain things are. Bats use sonar when they're flying. They squeal a high-pitched sound out of their mouths. Their sound goes and reflects off different barriers and boundaries. The bats are able to locate what's in the area because of sonar. So sonar is using any sound. Radar would be another one that uses light, also with reflection. Of a reflection, anytime you have a wave that meets some sort of boundary, the energy can't pass through it, it will reflect off of it. Let's talk about another wave phenomenon. This wave phenomenon I want to talk to you about is called diffraction. This is something that's very specific to waves, and diffraction is when a wave reaches some boundary or some obstruction that has a hole in it or is discontinued. What will happen is the wave and the energy of the wave will bend around the obstruction. And here you can see an example of that. On the left here on your page, you can see each vertical line would be a wave crest or a wave front. And they're approaching this wall, but this wall has an opening in it. As the wave strikes the wall, all the parts of the wave that strike the wall that is the wall, they either reflect or absorb by the wall. But here at the opening, the waves pass through the opening and it bends around the boundary. If you think about this, and let me show you another example. This is a partial boundary, so not an opening, but the waves are striking the boundary here in this right-hand example. And then behind the boundary, in the section that I'm hovering with my mouse, the waves kind of bend around it. You see the second example a lot if you've ever been on like a pier or you've ever seen waves lapping up against some sort of boundary that's discontinuous, and then the ripples kind of bending around it. That is diffraction. But another more common example you might have seen is just sound. If you've ever been in a room and you've heard someone out from a different room talking through like an opening in the door, the sound waves come and strike the opening. when they pass through the opening, the energy spreads out in all directions, so you don't need to have a line of sight with someone to hear what they're saying. You just need to be able to transfer the waves from one spot to another spot through an opening. So anytime a wave passes through some boundary, it'll spread out. This also happens with light. If you've ever noticed, hopefully you have, that if you have a window can provide light to the whole room, but it's not just where the light is shining through the window. When the light passes through the window, because light is a wave, it bends around and fills the room. So a window can spread light throughout a whole room, not just the part of that's adjacent to the window where the light is coming through. So those two wave phenomenon, I'm going to show you next a video of diffraction, which is a really good example, and I really like this video. So watch that, and then I will pick up on Doppler effect next.